Hi everyone. So today we need to have a look at the changes that happen at different scales, different time scales to the water cycle and the carbon cycle. So we need to look at daily changes, we need to look at seasonal changes, and then we need to look at some longer term changes and be able to talk about them all individually. So we've got this word diurnal. When we talk about diurnal changes, we mean daily changes. So the changes that occur within a 24-hour period. So if you think about the water cycle, and the best way to think about a daily change is to think about the water cycle during the day and the water cycle at night and how things would be different. So obviously at night we've got lower temperatures, so we've got less evaporation, less transpiration. In terms of rainfall, if we're talking about convectional rainfall, that is dependent on the sun heating the land, which is only going to happen during the day. So convectional rainfall is a daytime phenomenon. And as we've talked about before, it often happens in the rainforest and it is often an afternoon thing. When we get convectional rainfall in this country in the afternoon, think about when thunderstorms tend to happen. They tend to be early evening that we get those thunderstorms, that convectional rainfall. So particularly in the tropical regions, the bulk of the precipitation falling will be in those convectional storms in the afternoon period of the day. So what about carbon as well? So think about the diurnal flows of carbon. We've got photosynthesis occurring during the day, but photosynthesis doesn't happen at night. You need sunlight for photosynthesis to occur. So photosynthesis flow is only there during the day. At night, that photosynthesis flow of carbon from the atmosphere into the biosphere switches off. And the only flow happening is respiration, is that carbon going back into the atmosphere. And remember, that's exactly the same with the phytoplankton in the oceans. The photosynthesis of the phytoplankton is only happening during daylight hours. It's only happening during the day. Okay, so moving to seasonal changes. So if you think about the UK is the best example to use because we have 4 seasons. You wouldn't be able to talk about seasonal changes if you used the Amazon rainforest because there are no seasons. It's the same all year round. But in the UK, we've got our 4 very distinct seasons. And the solar radiation, the rays from the sun, vary greatly during those seasons. So, for example, we know that we get the most sunlight during the summer season, and it peaks in about the middle of June. So to put some figures on it, in June, our solar input in southern England where we live is about 800 watts per metre squared. In December, that drops massively to 150 watts per metre squared. And that change in solar insolation, change in the sun's rays, we know, we feel it, we know the temperature is much colder in the winter. That has an impact on the water cycle and on the carbon cycle. So evapotranspiration is much, much higher in the summer, much lower in the winter, because you need the sun's rays to cause that process of evaporation to actually happen. And in the summer, in the driest parts down in the south of England, up to 80% of rainfall can be lost to evapotranspiration in the height of the summer. And we get a very different picture in terms of our river flows in the winter compared to the summer. You may get a situation, as you can see in that photo at the bottom right, in the summer where there is so little water left in the system that the rivers essentially dry up. And then as we get into the autumn recharge, that water floods back in again and the flows are much greater during the winter months. Now you can have a look at this video clip here. I've linked to it at the bottom on Show My Homework. And you can have a look at the carbon cycle and how it really varies during the seasons. And this is looking at a global view. I think we might have actually looked at this in class before. And it's looking at the different latitudes and how that impacts upon the carbon cycle. So in the mid and high latitudes, the day length really drives those seasonal changes. So we've talked about the fact that in the Arctic tundra, that summer season, you've got 24 hours of sunlight for several months, and photosynthesis is constant for 24 hours a day, and the vegetation takes off during that time, but then very quickly falls away, and there's absolutely nothing throughout the winter season at all. And there's another clip here that you can watch, a YouTube clip, that again shows on a global scale the flows of carbon from the atmosphere to the biosphere. And we've got very distinctive differences in the carbon cycle and in those flows between the summer and between the winter. And when we looked at this before, remember we talked about the fact that the northern hemisphere has a much greater flow of carbon associated with the bigger land masses, the greater population that actually live in the northern hemisphere. And then it's all about the vegetation. So during the summer in the northern hemisphere, all of that vegetation that grows in the summer months is all photosynthesizing, it's all taking the carbon out of the atmosphere. And as a result, the carbon in the atmosphere is much lower during the summer months because all those trees are taking it out. But then in the winter, when the trees have lost their leaves and there's far less in the way of foliage, photosynthesis has dropped off massively, there's far less carbon being taken in, and as a result there's far more carbon in the atmosphere itself. And then remember, in the ocean, it's really important to remember that the phytoplankton is as important, if not more important, than the rainforests and the trees on the land. The phytoplankton do the same thing, photosynthesize, but this is, sometimes people forget about the phytoplankton and focus on trees and forests when they're talking about photosynthesis. And actually it's really important to talk about the phytoplankton as well. And photosynthesis of the phytoplankton is stimulated by warmer temperatures, obviously by there being more sunlight around. So when you've got that longer period of sunlight, more intense sun's rays during the summer, again, the phytoplankton are photosynthesizing and taking carbon out of the atmosphere much, much faster than in the winter. And then long term, so by long term I'm talking about millions of years. So how does this impact the stores and flows of the water and carbon cycle? So we know that we've had this fluctuation in temperature. We know that we've had these ice ages and interglacials throughout the Earth's history. And when you look at a graph like the one at the bottom here, in the last 400,000 years, there have been 4 major glacial cycles. Glacial, interglacial, 4 times. And each of those cycles has lasted around 100,000 years. The last glacial, the height of it was 20,000 years ago. And we know, and we particularly know these figures from coasts, that the temperatures in Britain were about 5 degrees lower than they are today. And most of northern England, Scotland, Wales were under ice that was about 1 kilometre thick. And if you remember from coasts, we were talking about the fact that that ice had pressed down on the land, and actually we've got isostatic change today where that land is still rebounding, still rising back up again from being under that immense weight of ice. During the interglacials, temperatures were similar today, but we do know that they have been higher. So about 250 million years ago, temperatures were 7 or 8 degrees higher than they were today. Now obviously these major shifts in climate have had a big impact on the water and the carbon cycle. So thinking about the water cycle, as we know, during the glacial periods, we had precipitation falling mainly as snow, which then turned to ice, and the water was then locked up in the ice sheets. And as a result, sea levels fell dramatically. Sea levels about 100 meters lower than they are today. And those ice sheets were growing. They were bulldozing the land, as we know glaciers do, and destroying forests, destroying the grass. So as a result, the amount of vegetation also shrank dramatically, which then also had impacts on the water and carbon cycle. In the tropics, the climate became drier, the deserts displaced the areas of rainforest, and so we had a situation where we've got far less evapotranspiration taking place. The flows that we would generally associate with the water cycle and the carbon cycle slowed down considerably. So we're basically thinking of, on a global scale, those water cycle and carbon cycle conditions we've talked about when we've talked about the tundra. Everything is very slow. There's far more stored than flowing anywhere. And obviously in glacial periods there's a massive reduction in carbon in the atmosphere. We know there's this very close correlation between temperature and carbon. When carbon is lower, temperatures are lower. When carbon in the atmosphere is higher, those temperatures are much higher. There's not a clear explanation as to why this is, but some scientists think that during the glacial periods, the carbon from the atmosphere finds its way into the deep ocean and it stays there. So you've got a possibility of changing ocean circulation, bringing nutrients to the surface. Phytoplankton goes mad, which takes in a lot of the carbon through photosynthesis. That phytoplankton then dies, sinks to the bottom of the ocean, and the carbon just stays there during the glacial periods. And then on the land, obviously you've got far less vegetation during a glacial. The ice sheets have bulldozed it. The temperatures mean that it doesn't really grow. And so the carbon stored in the soils is no longer being exchanged, is no longer flowing into and out of the atmosphere. You've got a huge amount of carbon that ends up being stored in permafrost. You've got far less photosynthesis taking place. So again, those flows really slow down and most of the carbon is stored. So you've got your questions there. I know some of you have made notes as you've gone along. That's absolutely fine. And there's a 10 marker there that you can have a go at if you want to. Examine the significance of short-term changes in the carbon cycle for 10 marks. And then, so there's a Spearman rank exercise there that you can have a go at if you want to. And then everybody needs to complete test 3. So I've uploaded it as a PDF if you want to print that out and do the questions. I've also had a go at turning it into a Google Forms document. So if you click on that and open it, you should be able to type your answers into that Google Forms document, submit it to me. That will actually make it an awful lot easier for me to mark and feed back to you, rather than having lots of people submitting it in all different ways and straining my eyes trying to read what people have answered. So if you can do that Google Forms link for the test, brilliant. If not, don't stress about it. You can do it the old-fashioned way if you like. Any questions, let me know.